What's up, everybody, and welcome to the Hydraulic Engineering Tutorial YouTube channel. Today, we show experiment number 7. To calibrate the given orificemeter apparatus, I, a long pipeline fitted with a sharp-edged concentric circular orifice plate and having inlet and outlet valves for flow regulation. I, a U-tube differential manometer connected to pressure tops at 1 diameter upstream and half diameter downstream of the orifice plate. Pi, a discharge measuring tank. IV, stopwatch. Theory: Orificemeter or orifice plate is a device, cheaper than a venturimeter, employed for measuring the discharge of fluid through a pipe. It also works on the same principle of a venturimeter. It consists of a flat circular plate, figure 5, having a circular sharp-edged hole, called orifice, concentric with the pipe. The diameter of the orifice may vary from 0.4 to 0.8 times the diameter of the pipe, but its value is generally chosen as 0.5. A differential manometer is connected at section 1, which is at a distance of 1.5 to 2 times the pipe diameter upstream from the orifice plate, and at section 2, which is at a distance of about half the diameter of the orifice from the orifice plate on the downstream side. Procedure: 1. Note the pipe diameter. D1, the orifice diameter D0 and dimensions of the discharge measurement tank. 2. Adjust the inlet and outlet values for maximum discharge. 3. Allow the flow to stabilize and then note the readings in both the limbs, H1 and H2, of the differential manometer. Determine the discharge by measuring the level rise, Z, in the discharge measurement tank for a particular time, T. 5. Reduce the flow rate by closing the outlet valve slightly. 6. Repeat the steps 3 to 5 for several different discharges. Take more readings in the lower range of the discharge. Precautions: 1. Ensure that there are no air bubbles in the manometer. 2. After each change in the valve opening, wait for some time for the flow to stabilize before taking readings. 3rd, time interval for collection of water for discharge measurement should be large. Don't forget to like this video and subscribe to the channel for more hydraulic engineering contents. Thanks for watching, and I'll see you in the next video.